Hello everyone. The cross entropy is using as a loss function in neural network for the classification problem statement. Here the negative likelihood is same as the cross entropy we are going to calculate between the actual output y and predicted output y cap. So here the equation can be given as hypothesis of y comma y dash the y cap, that means y is the actual output and y cap is the predicted output, equal to same as the negative likelihood. So negative log likelihood between the actual output and the predicted output. So here I is having the number of samples from 1 to m. So here the cross entropy can be using as a loss function after the softmax activation function we are going to use for multi-class classification problem statement in the given data set. So here the log transformation is using in the cross entropy. So the softmax function is given here, which is giving you maximum likelihood value here. Then we will take the output as a maximum likelihood. So from this we are going to calculate the cost by using the cross entropy. So here if the problem statement is binary class classification, we will use the binary cross entropy, or if the problem statement is multi-class classification, then we will go for cross entropy, that is the categorical cross entropy. So here when you are using the cross entropy loss with log transformation, we will not apply negative log likelihood. So when you are not applying the negative log likelihood, you will get the equation like h of y comma y cap equal to summation of I equal to 1 to m number of samples, then actual output into log of predicted output y cap I. So when you are applying the log likelihood for this equation, you will get the value in the form of negative. Okay, now for example, you may get negative 0.5 like this. So error should not be calculated in the form of negative. So that's why we are going to use here negative log likelihood to make that negative value into the positive. So minus of minus 0.5 will get you 0.5. So it can be done by using the uh, generalizing that multi-class classification problem statement. Here there is masking principle available. Based upon that, we are going to apply log likelihood for this equation. So when you are applying the log likelihood for the probability of given data with respect to the parameter theta equal to summation of I equal to 1 to m. So here we will write this equation log of predicted output of ith sample power yi. So when you are applying that m power log m power n, in the sense n log m, so like that we can write. So it is written as a yi into log y cap I. So here we are having a different loss functions, a negative log likelihood. So this is negative log likelihood and binary cross entropy and cross entropy. So when can we choose this different kind of functions for calculating the error? So loss would be calculated between the predicted output and actual output of each and every sample. And here whenever we are having the probability of the given sample is positive, then we can go for the binary cross entropy loss function. So here the y cap is calculated as positive value. So you if for example here the value, so directly when you are getting the value here positive value, then we can go for without log likelihood. Without log likelihood we can go for binary cross entropy. But when you are having the negative value, then we have to go for with the log likelihood. So that's what given here. The cross entropy loss is using for the functions whenever predicted output which is having two-dimensional output, and the actual output for that given sample is one-dimensional. So it will have the number of classes from 0 to c minus 1. That means c number of classes. That may be, for example, when you are using the negative log likelihood loss for the binary classification, so the multi-class classification may have more than two classes. So at that time we can go for any cross entropy loss with negative log likelihood. So here the negative log likelihood loss is applied whenever the predicted output is encoding the log likelihood. It should be essentially performed the masking step. So masking step in the sense, the log likelihood we are applying, after applying the log likelihood we will go for negative log likelihood. So that's what we are saying here. The cross entropy can be applied for multi-class classifications whenever y cap is encoding the raw prediction values that need to be activated using the softmax function. So here we will whenever we are using the multi-class classification by using the softmax activation function like this, then we have to go for the multi-class cross entropy, that is categorical cross entropy loss function. Thanks for watching.